Here in this video, we're going to look at one more example dealing with the quadratic function. We have a rancher that has 200 feet of fencing and wants to build two identical pens for his prize-winning pigs, and the pens will be arranged as shown below. Determine the dimensions of a pen that will maximize the area. So if we notice down here, we have the two pens. Uh, the bottom side has a length of x, and then we have a width of y. So that means across from here, this is also going to be x. And because the pins are going to be identical, that means this side is x. The length of here is going to be x. And then the left side here is across from the y, so this is going to be y. And you notice we have one fence that is going right through the middle. And keep in mind, this is only one fence. We don't need to have two going through the middle. So this one fence through the middle is shared by both pins, and that's also going to have a length of y. Now, we want to maximize the area. Well, we know that if we're looking for the area of a rectangle, area is equal to the length times the width. All right, now what else do we know? Well, if we think of this as area equals length times width, then we can look up here and figure out what is the length and what is the width. Well, if we look at all the way across from here to here, this would be 1x plus 1x. So the total length of both of these pins would be 2x. And then the width here is just simply y. So we could think of the area as the length, which is the 2x, and the width, we could think of that as our y. So 2xy is going to give us the area. So if we know the area is equal to 2x times y, that will give us the area for this particular rectangle. Now that's going to give us the total area here of both pins. Now we have 2xy. We want to eliminate one of these variables just like we've done in the past. So what other information do they tell us? Well, they also tell us that we have 200 feet of fencing. So to do this pin, or both of these pins here, we have a total of 200 feet of fence. Well, if we think of this as far as 200 feet of fence, we could think of that as the perimeter. So that's the distance all the way around, and also the fence that's going through the middle. So if we think about the total amount of fence, we know that across the bottom we have 1x plus 1x, and then on the top we have another x, and then another x. So that's 1, 2, 3, 4. So that's going to be 4 times x. So whatever the length is for x, we're going to have 4 times x, plus whatever the length of y is, we have 3 of those. So that would be plus 3y, and that's going to be equal to the total amount, which is 200 feet. So 4x plus 3y is going to give us the total amount of fencing that we have to use. So we can solve now for either x or y, just like we've done in the past. And I think for here, I'm going to solve for y. So that means 3y would be equal to the 200. We want to subtract the 4x. And then we can divide by 3. So y is going to be equal to the 200 minus 4x all over 3. So now that we have this equation solved for y, we can take all of this and substitute in for the y variable over here. So now we're going to end up with the area is equal to 2x multiplied by y, but we know now that y is equal to the 200 minus 4x divided by 3. Now, once again, why did we perform the substitution? Because now we have eliminated the variable y so that we simply have the area in terms of the variable x. So now we can simplify this expression a little bit. First of all, we could distribute the 2x. So if we distribute the 2x, we're going to simply multiply the 2x by each piece in the numerator, because keep in mind, this is really 2x over 1. So we're multiplying 2x times 200, 2x times a negative 4x, and on the bottom it's just basically 1 times 3. So if we multiply here, we're going to get 400x on top minus 8x squared, and that's all still over 3. Now here, to take care of the 3 on the bottom, keep in mind here the 3 has to divide in both pieces. So I'll do this one step at a time. This is really going to be 400x divided by 3 minus 8x squared, which also has to be divided by the 3. So we have to divide both pieces by 3. And if we simplify this, 400 over 3, we can, uh, let's see if we can reduce this. This is really not going to reduce any further. What we may want to do at this point is write this in descending order. I'm going to pull the 8x squared over 3 out front, so that's going to be a negative. And I'm going to write this as 8 thirds x squared plus 400 thirds x. Now, all I did there was for the 8 thirds x squared, whereas this was written as 8x squared over 3. All I did was write this out front as 8 thirds with the x squared. Okay, so that really means the same thing. So instead of having it divided, I pulled it out so that it looks more like the fraction as our coefficient of the x. So it's 8 thirds x squared. So that's all I did was pull the 8 thirds out front. Okay. And where that comes from, if you're not seeing that really clear, if you have x divided by, let's say, 2, then we could certainly write that as 1/2 times x. Because what happens when you multiply 1/2 times x? You're going to get x times 1, and then 1 times 2, so you're going to get x over 2. So all I'm doing is pulling the 1/2 out front. So here I'm doing the same thing, except for I'm pulling out the 8 thirds. All right, now that I have this in descending order, negative 8 thirds x squared plus 400 thirds x, this is our quadratic equation here. And remember, what are we trying to do? We are trying to maximize the area. So if I'm looking at this equation here, here's the area. We want to maximize this. Well, we know that the graph again of this parabola is going to open downwards, okay? And we're trying to find this maximum point. So again, this maximum point is our vertex. And how do we find the vertex? Again, we're looking for the vertex is the h and k. So if I'm looking for h, we know that's going to be the negative b over 2a. Well, in this case, we have a negative b, which would be a negative 400 thirds. Okay, so here's our b. And then our a is the negative 8 thirds. So that's going to be divided by 2 times a negative 8 thirds. Now keep in mind this h value here is going to be finding our x. Okay, so here this is the h value is representing our x, and the k value, which is our y, is representing, in this case, the area, which is a, for this particular equation. Now, the main thing we're trying to figure out is what is this x value? Well, we take a negative 400 thirds and we divide it by 2 times the negative 8 thirds. Okay, and what does that equal? Well, if you perform the calculations here, now keep in mind if you put this into the calculator, you need to make sure that you put the entire numerator in parentheses and the entire denominator in parentheses. And doing so, you will come up with h, or our x value, is equal to 25. So that tells us our x value is 25. Now, let's go back up here and figure out our x value is 25. So we know that this is equal to 25 here. So what else do we need to find? We need to find the y value. Well, that means we need to take our 25 and we need to substitute that in over here, and we can find the y value. So we would have y equals 200 minus 4 times 25 over 3. Okay, So here you would have 200 minus 100. So then you'd have 100 here divided by 3, which is going to be approximately 33.3. And again, that would be feet. So that tells us that our y up here has to be 33.3 feet, and our x would be 25 feet. So that would be the dimensions of one of the pins, where you have 25 feet by 33 feet. Now we can verify, does that match up with 4x plus 3y equals 200? Well, certainly if you take each one of these are going to be 25, and then each of the y's is going to be 33.3. And because we rounded this to 33.3, this is really 33 1/3. So if you take 4 times 25 plus 33 1/3, or 33.3, that will be equal to 200. So the dimensions here would be 25 feet by 33.3 feet. Because here they wanted us to define the dimensions of one of the pins. Okay, we're not looking for the dimension of the whole pin. So here the dimensions would simply be 25 by 33.